Let's go over a problem to see how z-scores can be used for comparisons for things with different units and different scales. Here we have two different exams, and two different students took these exams. You can see the first exam is easier than the second exam because the average score is a B on the first exam, where the average score on the second exam is a low C. The standard deviation is more spread out for that second exam, but it's less spread out for the first exam. Megan did worse on the first exam, even though it was an easier exam, and she did much better on the second exam that was much harder. Anna scored the same on both, so we want to know who performed better overall. We can compare these two students by looking at their z-scores for both exams. Let's start by calculating the z-scores for Anna. On the first exam, Anna got an 87. We subtract this from the average test score, which is 83, and then divide that difference by 5. This allows us to standardize the test scores so we can compare the first test to the second test, even though the second test was harder. On the second test, Anna scored the exact same, so she got an 87 again. But the test was much harder, and so her z-score is even higher because getting an 87 on that second test is a little bit more unusual than getting an 87 on the first test because the first test had an average of a B. Overall then, we can add up those two z-scores because they're unitless. So Anna's overall z-score is 2.01. When we calculate the z-scores for Megan, we'll see something slightly different. So on that first exam, Megan scored below average, and so her z-score should be negative. So we subtract her score of 76 from the average for the first exam, which is 83. We divide that difference by the standard deviation to get our z-score, and that gives us a negative z-score of negative 1.4. So on that first exam, Megan is below average by 1.4 standard deviations. But she was above average on the second exam. You can see she got an A on that second exam, even though the average for the second exam was a low C. Now we want to account for the fact that there's more spread in this second exam. And so we're going to take her score minus the average and then divide that difference by the standard deviation, and that's what gives us a z-score of 1.5. So now we have two z-scores for Megan, and we can add those up because again they're unitless, and overall her z-score is 0.1. So in comparing these two girls and their exam scores, we can see that Anna performed better overall because she scored above average on both exams, whereas even though Megan scored much farther above average on the second exam, she scored very below average on the first exam, which was actually the easier exam. So this outweighed any of the benefits she got from scoring above average on the second exam. So that's how z-scores can be useful for comparing different groups of things, and even different things that come in different units and different scales. In the next video, what we're going to look at is how we can use z-tables and answer questions using those z-tables.